Welcome to Debug Diaries by CSE, a podcast where we dive into the world of technology with some of the most influential minds shaping its landscape. Join us as we experience the past, navigate the present, and envision the future of innovation and technology. Today we welcome Mr. Menan Velayuthan, who is currently reading for a Master's by Research at the Computer Science and Engineering Department at the University of Moratuwa. Menan has dedicated his career to advancing artificial intelligence with a focus on neural machine translation for low-resource languages. He has worked as a research engineer and a research assistant at the University of Moratuwa, and his work bridges theoretical as foundations and practical applications, significantly impacting AI technologies across various industries. We look forward today to exploring insights into the evolution and the future of LLMs with Mr. Menan. So, good afternoon, Mr. Menan.
Good afternoon.
Really excited to have you on the podcast today. So, I think our viewers would like to know a bit about yourself and the work you do at the University of Moratuwa.
Sure. So my career started in the industry. So I started as a data scientist at Stax LLC, and then that's where I got my primary knowledge in NLP as well, where we actually solve business problems using NLP. So through my passion for AI, I switched to my careers into research. So initially, I went to SLIIT for a World Bank funded project on detecting head pose estimations for children in spectrum. So finally, there was a Google project, Google funded project by Dr. Nisansa and Dr. Surangika. So I applied for it, and I ended up in University of Moratuwa as a research engineer.
Right. So you mentioned that you were a research engineer at the University of Moratuwa, but you're also reading for a master's of research. So could you explain to us what your work is involving at the University of
Okay, so initially it started as AI research engineer, not as a master student. So initial responsibilities were, it was mainly dedicated for the project itself. So we were building, we are still building a multi-domain data set for machine translation to improve the translation quality of, for low resource languages like Sinhala and Tamil. At the same time, we are also planning to build a robust model which can take in multiple domains as well. So during that time, it was suggested by my supervisors to also start reading for masters, which will be beneficial. So then I switched into that as well.
Right. So you mentioned languages and models. So in today's world, if you talk about languages and models, what comes to mind first is large language models. And you have to be living under a rock if you have not heard about today's large language models, including ChatGPT, Gemini, Deepseek, and etc. So can you touch a bit upon the large language models, their origins, and where they are headed?
Sure. So how it started was so before large language models, it started with language modeling. So in the early 2010s, this became much more popular. So the reason for the current wave of AI could be boiled down to three reasons. One is the introduction of the transformer model. Second, also the introduction of self-supervised pre-training. And finally, this concept called transfer learning. So these three concepts together actually popularized large language models into the industry as well. So now it's a common household name as well. Not only restricted to people in AI research, but also broadly available for many others as well.
Right. So when you mention the key architectural innovations, can you also talk about a bit of the training methods behind LLMs that make it successful, which make it so easy for us to do our various works with LLMs today?
Okay, so how it started was like at the beginning, there were so the biggest, toughest thing we had was this concept called sequence modeling. So it wasn't as easy as like other traditional ways of approaching deep learning. So sequence modeling is where because naturally language is a sequential data, right? So when we talk, it's a sequence of words coming together. So how do we make the LLMs, or sorry, what do you call, the model understand this was the toughest one. So it started with recurrent neural networks, but it had a bottleneck, right? So because of the recurrent neural network had to do things in sequence, we couldn't completely utilize the GPUs, right? So then because of this, due to this, there was a key paper which was out, Attention is All You Need, which introduced transformers. This actually enabled us to train data in a much more parallel way, in a much more efficient way, and therefore this allowed us to scale it up even further and utilize GPUs in a more efficient way.
Right. So you mentioned how parallel computing was influential in these LLMs becoming mainstream today.
Uh-huh.
So could you give us a bit of an understanding on how the rise of GPUs fuel the LLM hype that we are seeing today?
Sure. So how it started, I mean, it's not, so rise of parallel computing or rise of GPUs didn't only popularize LLMs. So it actually popularized deep learning as well, right? So at the beginning, people trained using machines like CPUs and everything. But what they realized is that that's going to take much longer time. So instead what they started shifting towards is this something which was dedicated for something else. So graphical processing unit, which was mainly dedicated for for visualizing and for video editing and those kind of graphic contents. They realized that okay, inside that there is so many smaller versions of GPU cores. Like, so what that does is it's a replacement for CPUs. So now, still now, CPUs are faster, but what GPU achieves is you can do a lot of things at the same time. So because of that reason, people shifted towards GPUs, and with that, we were able to train larger models, plus with larger data sets as well, because we have to understand that AI is a data driven problem, right? So when we successfully achieved that larger data, then we were in the right path.
Right. So when you mention about larger models, larger data sets, we could think that, LLMs have reached the peak of their powers. But there are still developments going on around large language models. So could you mention a few of the technical or ethical uh, issues that we face when training and developing these large language models?
Okay, so um, yeah, so it's true that we are going towards some sort of a saturation in LLMs. The reason is because uh, like how fossil fuel helped in the industrial revolution, right? Uh, Data was the new fossil fuel. At the beginning, we were able to utilize very less data. Now we almost utilize the entire internet. So, and we have only one internet, right? So data has now come to a saturation. So that is the reason why we feel that LLMs also might saturate. So the technology is now, so it will come back to, like, imagine it from a space exploration, this thing. So initially they built rockets, right? They didn't bother about cost. All they cared was they wanted to send the rocket to the atmosphere or wherever they want, right? So then the cost didn't matter. Right after that, now if you take SpaceX and everything, they reduce. Now what they try to do is, how do we send the rocket but also do it in a lower cost. So that's what currently people are trying to innovate. How do you shrink that model so that it can be utilized in a phone, right? Because right now most of the models need still that high power processing power, so it's hosted in servers, right? So now what people are thinking of is, how do we efficiently do it? So now, and the other point is, ethical concerns are also still there. There is enough examples, especially in AI, especially because it's data driven. Because internet is it goes two ways, right? I mean, there is not only the ethically correct and morally correct data. There is racially biased data. So there is something called rail guarding, so which is already done within the LLMs itself. So it kind of blocks the LLMs to not go in the wrong direction. So those are kind of things which we are currently researching on, how to filter out those data out of the training data set.
Right. So you mentioned about how LLMs have become so large that we now have to start looking at the costs and the efficiency of these LLMs. So one innovation that has been making waves in the recent past is Deepseek, which was LLM released by a Chinese company. So I think Deepseek R1, which was a very advanced reasoning model, has been making waves in the AI industry. So could you elaborate a bit about Deepseek and what makes it different from the current state-of-the-art LLMs that we have available?
Right. So what makes it different is not from an architectural point of view, because they haven't done something which is very much innovative, which is unique from that end. So what they skillfully did was utilized a lot of proposed methods from various companies, or not only companies, but by the research community, and they married them together to achieve this. What makes them very important is that they have a direct comparison with with OpenAI's models, which so the previous open weight models like Llama and everything, they came close, but they didn't achieve this kind of a achievement. And what makes them even more outstanding is that they did it with a team of nearly less than 200 people. Whereas when you take these big tech companies, it was always this idea that LLMs or anything connected to LLMs needs to be done by a massive company with large fundings and large GPUs. But what these people did was, I think, if I'm not mistaken, nearly under the budget of 6 million US dollars, right? So in a lot of areas, they efficiently did this. So one key innovation which they did was this reinforcement learning in the purest form. So it stood out from the previous versions. So there were like tiny innovations, but nothing was new. It was just how they married them together.
Right. So, when you mention optimization strategies, we also heard about a few smaller models that DeepSeek is offering. And these smaller models also offer like a lot of thinking power and whatnot. So, could you elaborate on what optimization strategies that they use for these smaller models as well?
So so the biggest, the one which is performing on par with OpenAI is their bigger version, right? The ultimate version. So these smaller models are like actually fine tuned or taken from other open weight models like Mistral, Llama, and those kind of things. So what they did was they used this thing called distillation, knowledge distillation. So in essence, basically. What the key idea is, so imagine you have a book, right, like a mathematical complex book. So if you go to read about it, you're going to find it difficult, right, to read it. Instead, if you attend a maths lecture where a lecturer has read that book and is teaching you in that way, right, so it's that condensed knowledge is now much more simplified for you. So what they did was they asked this bigger R1 model, right, to generate synthetic data, and then that acted as a teacher. And basically what they did was those generated synthetic data is now used to train on the smaller versions. So there are other optimization techniques like uh, uh, what you call quantization, LoRa, but those are in the fine tuning stage. So there is like, especially in the initial training stage, there is no replacement for the actual full on training. So it's during this fine tuning where you make it task specific, you use these higher optimizations.
Right. So with the emergence of DeepSeek, we see it has caused a ripple in the AI world. So what do you think are some of the real world implications of DeepSeek advancements? And how do you think it may change the AI landscape for the upcoming years?
So what DeepSeek has successfully done is it has showed that you don't need much resources to achieve a very state of the art model. So instead of people, and the other thing, the disrupting thing they did was they open weighted it, right? So the key difference between open weights, open source, and closed weights is that open weights model are models where you completely open source models are models which you completely open source everything from the data to the training code and to other essential metadatas. Uh, what companies don't do right now is that they open source everything, because there are some legal issues as well, because as some open AI face, like even JK Rowling sued open AI, saying that Harry Potter books were were part of the training data set, but they couldn't prove it because the data wasn't open source. So that's the reason why people now open weight is, that means the only the model is released, so there is no very difficult to prove that this sort of data was used. So how you can, like, how it can apply is that instead of using open AI, now people will start using Deepseek model, which is open source, and they will house it in their local server, because there's always the concern of data privacy, because when you are using open AI, you are actually sending your data to the to open AI itself. But what Deepseek has allowed is, given a model which actually performs as much as a what you call OpenAI, but now you can actually host it inside your company, given your enough resources. So with that, there is like mountain of what you call opportunities, like text classification, even chat systems, customer chat systems. So I mean the opportunities are like endless actually.
Right. So I believe that, these open sourcing these models can truly benefit the future of this technology.
Yeah.
So another key factor about DeepSeek that makes it special is its reasoning capabilities. So do you think, I think that has also prompted, even OpenAI a few days back to release their deep research capability. So given all of these reasoning per se that they speak about, do you believe that general intelligence, or AGI as it is so generally termed, are we on the brink of AGI?
Uh, yeah, that's a good question. So that's a common notion, right? So like, just because I would say right now it is creating an illusion of AGI, but not exactly, because so when we ask questions and when it's like responding to you in a more natural manner, you feel that okay, maybe there is some sense of self consciousness and intelligence within that model itself, but we haven't reached there. So there is research showing in what you call neuroscience as well, that thinking and reasoning is actually detached from the language side component of the brain, right? It's not always interconnected. Sometimes we may think that inside our mind we will logically, like, use language to think, but that's not always the case. So you, like, completely relying on a language based model and trying to achieve reasoning or human level reasoning is a very I don't think it's doable. So we are at the beginning. We have just scratched the surface. Of course, LLMs will have its own place, but it's not going to lead us to the AGI as we expect.
Right. So as you mentioned, uh, the LLM development, we are becoming bigger and bigger in terms of the size of the models, the data we use.
Mhm.
So do you think that we will see a plateau in the development of LLMs? Because we've heard about the compute efficient frontier, which the LLMs cannot cross. And so the bigger we get, do you think that the development of new LLMs will plateau, or are there some key areas that are still left for us to explore?
Yes. So, like I mentioned before, there is going to be a saturation because of the now limitation of data, because we did not expect for us to scale to this level this fast, right? So if you see, like, it's an truly an exponential growth. So GPT, I think the initial GPT models were in the they were released in the early I mean early 20s, right? 2020s, in that range. But then after that, with a small time gap, there is so much of what you call innovations happening, and most of the innovations have come through like how the making the model bigger, as well as making the data set which you are training on it also bigger. But at some point that data is going to stay as constant, right? Because there is say that there is like a big amount of data, but it's constant. So no matter how much you increase the model parameters to make the model bigger, as long as the data gets stuck there, scaling it blindly won't help. So now what has to happen is there are other innovations going on. There is something called fast memory. So all of this starts from a simple what you call innovation to because like right now when we use LLMs, it utilizes the entire LLM model. But when we think, right, we do not utilize the entire brain, right? So there is certain aspects, or like at least from our memory, we retrieve certain aspects and then we compile an answer or our thought, right? So there are research going on how to have localized memory or fast memory, where when LLM is interacting with a person, it will basically what you call utilize a certain aspect of it, right? Not the entire of it. So there are innovations going in that end. So right now there'll I mean soon there'll be a pause on just scaling. There'll be more innovations on how do we utilize what we have even better.
Right. So when you talk about the efficiency side again, and you mentioned fast memory, if I'm not
Yes.
mistaken. Could you elaborate a bit more on like how this works? And I think this was a paper published by UC Berkeley, if I'm not mistaken.
Yes, I think Jeffrey Hinton was the main person who actually I saw his talk. So he was the Nobel Prize winner
Yeah.
last year for his paper Boltzmann machines, right?
Right.
So fast memory is basically a short-term memory. So the thing is this, right? When you think about LLMs, like I mentioned before, it is a massive matrix, right? But how our biological brain works is that we sometimes retrieve things which are very crucial, for that session, right? So fast memory is also something of that sort, where like during inference you what do you call you utilize a certain amount of information, and you play with that rather than being able to like giving access to the entire knowledge, right? So then the compute becomes smaller, and the your answers also might become precise. Rather than you like given the entire world knowledge, you are now working in a small area. So yeah.
So I think, as you mentioned, that would be the key to achieving more faster and more customizable models,
Yes.
which anyone could run. I think Deepseek has really unlocked that capability,
Yeah.
where now you can even run a big model, a reasoning model on your laptop and maybe even your phone.
Mhm.
So I think we are really excited with what these LLMs are going to be going forward. But LLMs this, LLMs that. What about us? So when you talk about LLMs, most of these LLMs are in English and other very popular languages. But one of your research areas is how you optimize them for low resource languages like Sinhala or Tamil that we are majority used in Sri Lanka. So could you comment a bit about what is the future for these languages and LLMs?
Right. So there is enough research in the community which actually says that some languages are unfairly represented. So in that sense, so these what we call these LLMs, like Llama, OpenAI, they are English centric LLMs. Sometimes you might feel that they work well on Sinhala, Tamil, but that's by accident. And why I mean by accident is because you train it on a massive corpus of data, where there is no guarantee of there is no restriction of what language is present inside the data, because it's massive. So obviously by accident it's going to be learning other languages as well, but that doesn't mean that it's very thorough in it, right? So recently in my research also we published in Calling, where we actually showed that for languages like Tamil and Sinhala and Hindi, that the number of tokens required. So we actually compared with translations. For English, if there is like say 5 tokens, you need 3 times as many tokens required to for to represent a sentence in Tamil or Sinhala or Hindi. So what the implication of this is, when you have these what you call commercial models, they actually charge or tax the user on the token count. So if you need 3 times as more token to convey the same information, what happens is the person who is going to interact in their native language is going to get punished unfairly, first of all. Secondly, there is another concept called context window. That means how much that LLM can focus on. That is going to be reduced by 1/3, because you need 3 times as much as more tokens to represent the same information. So what we have to do is, like, we have to focus on initially, first of all, at least, to focus on collecting data in that large scale, right, for Sinhala and Tamil, because no one else is going to do it other than us, right? So we have to focus on that first, and then maybe jointly develop a very large scale LLM for which works well on Sinhala and Tamil as well.
Right. So I think that is fairly representative of how we should work to make sure that LLMs are accessible not just to the majority, but to also minorities
Yeah.
like people living in our country. So I think we are on the frontier of a renaissance in technology with LLMs and AI. So how do you think Sri Lanka should position itself when it comes to these large language models?
Okay, so that's interesting. Um, so we are so how we should position is like, so the analogy I normally use is the ripple, right? So you drop a ripple, like you drop a stone in the middle of the lake, and the waves take late to come to the what you call the shore. So we shouldn't always be at the shore, right? Because we have to be at the forefront, right? The waves come in a delayed way. So what happens is, like, the world has moved on, but we are now only getting the information. So that has to change. I'm sure that there is great initiatives not only from University of Moratuwa, but other places, other universities as well. Because right now, what is key is, you know, we have to start relying on ourselves, right? So relying on ourselves means we should encourage, we should actually by law encourage, data collection, because then there must be, legislations, detailing or outlining how data collection should be. What is meant to be private data, and what could be collected as open data. Because now we have to go and ask permissions for everything, right? So with that, there is some kind of a lag, because so once we start from a legislative point of view, as well as from the technical aspect, as you know that researchers also need to, what do you call, I mean, research positions also need to be well funded, so that we encourage the young talents to move into research as well, as much as going into the industry as well. So in those two aspects, if we focus, we can actually build not only LLMs, but state of the art AI technologies, which will be housed and which will be catering to Sri Lanka itself, with our cultural diversity. Right now, we are borrowing it from others, so we are borrowing their culture as well, right? So we need to build things which will actually cater our needs.
Right. So I think that perfectly summarizes what we need to do as a country, as a society, to make sure that these technologies are implemented, customized to ourselves. So thank you, Mr. Menon, for that wonderful and insightful session that you did with us. And I'm sure that our viewers got a vast amount of knowledge from your discussion with us. And we just touched the surface of LLMs, if I'm not mistaken. And there's much more that we can talk about. So we hope to see you again in another episode of our podcast. And to our viewers, thank you for joining with us today. And we hope to see you on the next episode of Debug Diaries by CSE.